Okay, this is student handout 4, measure of variability. Alright. So, the measure of a variability is a way to describe how far spread out the data is. So sometimes we can have like the average of basketball game points I score in a basketball game, and like one game I couldn't play or something, and so I scored no points that game, but all other games I scored points in the 20s. My data could be very spread out because of that 0 points that I scored that one game. So this is what our lesson kind of talks about today, is seeing how spread out our data is. It can also be described as how much the data deviates from the center. So that 0 that I scored in a game, and I averaged 20 points a game, it's deviated from the center because it's so far off of the normal. It's just not normal. So we have something called an interquartile range. The abbreviations for that is IQR. And it is a measure of variability that splits the data into 4 quartiles. 4 equal size quartiles. That kind of sounds like quarters. There's 4 quarters in a dollar. So that's why they called it quartiles, equal sized. So interquartile ranges splits the data into 4 sections. It is represented by, it represents the middle 50% of the data. It can be found by first ordering the data from least to greatest, just like we did on yesterday's lesson. Then again, finding the median, so same thing. Then once you find the median, you're going to find the median of the lower half, and then the median of the upper half, or quartiles. That's how we're splitting it into 4 sections. Then to find the interquartile range of that, to find the range, you subtract something, like the range in my highest game and lowest game, you would subtract that. So, subtracting to find the IQR, the interquartile range. You will notice on the sheet you picked up yesterday, these steps are listed there for quick references. If your IQR is small, that means your data values are closer to the median. But if my average scores per game, I had a 0, and then my other games, this game I scored a 32, I scored a 29 one time, a 34, another 34, a 35, a 35, another 35 a game. Okay, if I found my median, and if I subtracted my smallest and lowest, if it's closer to my middle number, then it's going to be a smaller value. You want it to be a smaller value, or that means you have these weird out-of-the-box answers like a 0. Or maybe one game I was on a roll and scored 90-something points. Okay, these are kind of known as outliers because they don't happen a whole lot. They're way off of my normal game. Here, this is my normal games. That's pretty normal. Not scoring any is not normal for me. Scoring a lot is not normal for me. Be good, but it's not normal. Alright, so let's work with interquartile range. So this first problem, we have a data set below represents the different cost of a camera at a local photography store. We want to first write the data from least to greatest. That's our steps. Step 1, write at least to greatest. So it looks like my smallest number's $28, then 36, 44, 59, 66, 71, and then 108. Wrote them for least to greatest. Okay, B says, what is your minimum price? Well, now that they're in order from least to greatest, I see my minimum price is obviously 28. What is the maximum price? Well, that's pretty simple to see. 108. Alright, our median. We found how to find the median yesterday. Cancel, 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 cancel. And I see my median is 59. It's my middle number. Now talking about our quartiles. What is the median of the first half of data, the first quartiles? Well, this is my first half of data. I'm not going to use this number to find my middle number. So looking at these three numbers, what is my median of these three numbers? I see that it is 36. That's my middle number. So I'm going to call that 1Q because it's my first quartile. This was my median overall. This says what is the median of the second half of the data, the third quartile. Well, here's the second half of the data, those three numbers. What would the median be? Be 71. So that's my third quartile. So I have my first, there's 4 quartiles, remember? First, second, third section, and then your fourth section. It's kind of broken off into line segments here. 4 sections. So your third quartile is 71. So to find an interquartile range, we have to subtract our third quartile. This is by the way, this is acting like my second quartile, or your middle. So there's 1, 2, 3, and there are your 4 sections. Alright, so to find your quartile range, all you have to do is subtract your third quartile from your first. My third quartile was 71. I'm going to subtract it from 36. And I see that my quartile range is 35. So is 35 is my quartile range. Alright, let's try that again with another problem. Number 2 says which of the following set of data represents the number of cars running the red light at the intersection of Main Street and Avenue A over a period of 2 weeks. Okay, we have to find the median and the interquartile range. To do so, we first have to put these data points in order from least to greatest. That's step 1. So I see my smallest number here is 6. Then 8. And I have 2 sets of 9s, I believe. Next would be 10. I don't see any more 10s. Then I have an 11. have a 12, no 13s, there's a 14, two sets of 15, and looks like I have 18, 19, 20, and 21. I used an 18, 19, 20, and 21. Okay, there's all my numbers. So I need to find the middle number. So I find that 12 and 14 are my middle number here, my median, so that means 13 is going to be my median, because 12 plus 14 would be 26. 26 divided by 2 gives me 13, so my median is 13. Now I have to find the interquartile range. Alright, okay, last problem we did, we only had one number as our median, so we did not use that number when we found our lower half of our quartile median and our upper half. But this time I have two numbers that's with my median, so 13 fell in the middle. So I am going to use this 12 when splitting my data. So if I'm going to find the median, I find that 9 is my quartile 1. I used that 12. Last time I did not, because there was only one number, so I used the ones to the side. But if there are two, you use it. So finding my upper half of the quartile, I see that it is 18. So quartile 3 is 18. To find my quartile range, I subtract those two. So 18 minus 9, and my interquartile range would be 9. It said the lower this interquartile range number is, the less spread out your data is. So it is a little bit lower than last problem we had. Or it's close to the median. Okay, to the back. We have mean absolute deviation. Its abbreviation spelled MAD. Mean absolute deviation measures the spread of the data in relation to the mean. You will find that the steps to this is also on your little sheet that you picked up the other day. To calculate the mean absolute deviation, you must calculate the mean of the data first. Then you have to find the difference between each piece of data and the mean. So you're going to look what the mean is and subtract it from every single piece of the data. Then number 3, you take the absolute value of each deviation. Remember, absolute value is the distance away from 0. It's always a positive number because distance is always positive. Then lastly, you take the sum of the deviations and divide it by the number of pieces of data. This will give you your MAD number, or mean absolute deviation. If your MAD number is close to 0, then that means the data values are close to the mean, the average. They're not real spread out, like my points per game. If I end up getting a MAD score that is close to my average, that means I don't have a lot of off games affecting my data. Alright, so it's kind of confusing of how to do this unless you actually work a problem, so let's get started with the steps. So number 3 says 7 different students were asked the number of family members in their household. Use the data to complete the table. Okay, so here's the 7 different families and the number of family members in each of the families. So, step 1 in my steps here says to calculate the mean of the data step, which means find the average. So I need to find the average of this column here. So I need to add them all up and divide by 7, the number of families I have. So 3 plus 2 plus 4 plus 2 plus 5 plus 6 plus 2 equals 24, divided by 7, and I get 3.428. So I find my mean is about 3.4. That's my average. So the average number of members in a family is about 3.4. That was step 1. Step 2 says find the difference between each piece of data and the mean. Okay, so what that means, this first piece of data is 3. How far away is 3 from a 3.4? It is -4 away, because 3 minus 3.4 gives me a -0.4. Okay, same thing with this one. 2 minus 3.4 gives me a -1.4. 4 minus 3.4 gives me a +0.6. And then 2 again is going to give me that -1.4. 5 minus 3.4, that's going to give me a +1.6. 6 minus 3.4 is going to give me a +2.6. And then 2 minus 3.4 is going to give me a -1.4. Okay, so I found the deviation, how far it was from the mean. Step 3 says find the absolute value of those deviations. Absolute value is just the positive form. So how far away is a -0.4? It's a +0.4. So it's all the positive forms. Okay, then lastly, I wasn't supposed to show you this yet. To find your MAD score, your mean absolute deviation, these are my absolute deviations right now. To find the mean, which is the average, I'm going to add all of these up and divide by 7. When I do, I get 1.3. So, my mean absolute deviation score is 1.3. And again, the closer that is the 0, the closer my average, my data values are to the average. Notice how most of these are pretty close to 3.4. That is why 1.3 is pretty close to 0. So again, all I did was found the average, subtracted my data from the average, took the absolute value of those, then I took the average of this data set to get my MAD score, my mean absolute deviation. It says to explain what this means for the size of families surveyed. The average number of family members were 3.4, and most family members deviated from that by 1.3. So 2 to 5 members encompasses most of the data. Okay, let's try another one together before you do your homework by yourself. In a science class, an experiment required counting the number of M&Ms in a small package. Use the data to complete the table. So, I have 11 green I have how many data points here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different bags sampled of how many green M&Ms were in there. I need to first find the mean of green M&Ms. So I'm going to take my calculator and calculate the average. 7 plus 9 plus 4 plus 12 plus 3 plus 2 plus 9 plus 8 plus 3 plus 11. I get 68 divided by the 10 bags. I get 6.8 is the mean, the average. So I need to find the deviation from 6.8. So I do 7 minus 6.8, that gives me a positive 0.2. 9 minus 6.8 gives me a positive 2.2. 4 minus 6.8 is going to give me a negative 2.8. 12 minus 6.8 gives me a positive 5.2. 3 minus 6.8 gives me a negative 3.8. 2 minus 6.8 is going to give me a negative 4.8. 9 minus 6.8 gives me a positive 2.2. 8 minus 6.8 gives me a positive 1.2. 3 minus 6.8 is going to give me a negative 3.8. And 11 minus 6.8 is giving me a 4.2. So, step 3 says find the absolute value of all that. Well, the absolute value is the positive form of all those numbers. So here's my absolute deviation. They're all positive. So to find the mean, I need to add all of these up and divide by 10 because there's 10 different bags. So I'm going to do 0.2 plus 2.2 plus 2.8 plus 5.2 plus 3.8 plus 4.8 plus 2.2 plus 1.2 plus 3.8 plus 4.2. Okay, I get 30.4. There are 10 bags, so I divide by 10. I get 3.04. So my mean absolute deviation is 3.04. Does the MAD represent a large or a small amount of variability and why? So to determine if it's large or small, you got to look at what numbers you were dealing with originally. Compared to these numbers sampled, is 3 relatively small or large in comparison? And I would say this is a large amount of variability, considering the number of M&Ms in the package is pretty small. So if you're off 3 M&Ms in a bag that only had a few M&Ms to begin with. That's a pretty big deal. Alright, so you're going to work on homework 4. Your geo packet needs to be turned in before you leave, and this homework will be checked on Tuesday.